All right, well, I know we've got the attendee party when I'm done, so I don't want to get started late. And I probably won't run long either.
We've got the bears, so it's no problem.
But I'm glad you guys came up here today. We're going to talk about pattern matching. This is a feature in C#7 that I have been excited about since long before it was ever actually in the language. I'm an F# fan. I wouldn't say I'm an F# developer, because when I hang out with real F# developers, they're way better than me. But from playing with pattern matching in F#, I've always wanted it in C#, and now we finally have it. So we're going to take some time today to look at what it is and how cool it is and why you want to use it. My name's Eric Potter. You can follow me on Twitter at PotterEric. When I'm here in London, I get asked about my family quite a bit. Yes, I am related to Harry Potter. I got to visit him and his wife, Jenny. It was a good time, but weird stuff always happens. I was telling him about my pattern matching talk, but he doesn't care about C#. He's a parcel mouth, so he only ever wants to do Python. This is some code from the Roslyn codebase, actually. So this runs in your C#6 compiler. And it's C#6 code. And it's totally fine. There's nothing wrong with it. Other than it doesn't use pattern matching, because we didn't have it then. But what we can do with pattern matching is say, reducio. And we can shrink it down to this. Just looking at a quick side-by-side comparison, you can see that this is much cleaner, much terser code. Here's another block of code. This is from a different open source project. And don't worry about it. I'll get into the details of this later. I just want to show you why this is so cool. But I could take all of this code from C#6 and reduce it down to that in C#7. It's pretty good. So what is pattern matching exactly? If we think about it, it is a language construct that we've not had before. When I talk about language constructs, I could say things like we have iteration constructs like while and for, and selection constructs like if and switch. And since the beginning of C#, we've had these more powerful structures, or a more powerful structure for iteration in the for each loop. And we've never really had a more powerful selection statement until now. This is what pattern matching gives us. In the same way that a for each loop doesn't really give C# developers anything that you couldn't do with a do while loop, pattern matching doesn't give us anything that we simply couldn't do before. But in the same way that I'm guessing you guys use for each loops all the time, pattern matching is one of those features that you'll start to use a lot once you understand it and understand how it can benefit your code base. To get a better idea of the importance of this feature, I wanted to step back just for a second and talk about some history. And this goes back to 1972, where Dijkstra said that we have now seen 3 types of decomposition, and we could call them concatenation, selection, and repetition. That's kind of hard to understand. Uncle Bob has said it more modernly, where he says, once you strip away all the syntactic sugar, our programming languages essentially boil down to 3 things: sequence, selection, and iteration. Every construct within these languages is a combination of these. So these are like the 3 fundamental building blocks of any programming language you've ever seen. And what pattern matching gives you is an improvement in one of those 3 fundamental constructs. So it is simultaneously not something that you couldn't do before, but something that really improves the language at a very core level. So let's look at some code. Let's say that you are working on a WPF application, and you need to be able to reset all the controls on a given form. The user has entered some data. For whatever reason, they don't like it. You just want to set it back to the default state. Well, what we can do is loop through those controls, and depending on the type of control, we're going to have some different behavior. So we can get the main grid.children and just loop through them and then check their types. And given the type, we will then cast it from the control, which is our iteration variable, to the more specific type of either text box, radio button, or combo box. But because we want to be able to say is checked, it's not enough simply to know that the control is a radio box. We have to cast it as a radio button. Nothing really wrong with this code. But with pattern matching, we could write it like this. There's a couple things going on here that I want you to recognize. The first is that we are switching on an object that is not either an int or a string. In C#6, switch statements only worked on things that could be resolved to integers or strings. Now we can switch on anything. And what we're going to match on in this case is the type of that variable. And it's going to switch on the dynamic type. So the static type of the variable named control is control. We want to know what the dynamic type is. What's the more specific type here? This is called the type pattern, where I'm actually going to match on the type. And so now I can say text box, and if control is a text box, that variable will be populated and will be given that type. So we now have a text box variable whose type is text box, or we would have a radio button variable whose type is radio button, and so I could say radio button.isChecked. So there's no need to have that additional cast in there. So this cleans up our code quite a bit. The old way is on, let's see, my right, your left. The new way is over here. This code would be significantly shorter if it wasn't for the break statements we have to have. But you can see how this code is cleaner and more readable. It's, yeah.
Just had a thought, what's with the base types for those controls? Because all of them in WPF inherits from the main control. And if I would have a case statement for that main control, which one would it go to? You know what I mean?
Okay, so you're asking about what if a control, if we had a variable that matched at two different levels in the inheritance hierarchy?
Yeah.
That's a great question. How about, I promise you I'll answer it in like 15 minutes.
Sorry.
No, it's an important question, and there's some interesting ramifications, which is why we'll circle back around to it. So there's another new language feature that we have that goes along with this. This is another variation of the pattern matching code we just looked at. But if you've done any WPF, you know that a combo box could be editable or not, and so we might need to have different behaviors based on whether or not it's editable. So we now have this new when statement. This when statement is called a guard. And so what I'm saying now with this line of code is I don't want to match simply when the type matches, but I want to match when the type matches and this other expression evaluates to true. So I now have two cases for combo box.
How do we start the most specific one at the top?
Yeah, so the question was if it would match two, which one would it match on?
Yeah, probably the first one.
Yeah, so it's going to match on the first one that's true. If the order of these two was flipped, we'd actually get a compiler error or a compiler warning, because it would say that there's two that match, and the second one the more specific one would never be reached. But if we put the one with the guard first, it could match. And if
different guards?
Excuse me?
You could have different guards on it. So you have another that is editable, but you could have one above that. Some other property.
I believe so. Yeah. So the question was, could you have multiple cases with guards, and I believe so. I mean, as long as the guard has the evaluates to a Boolean expression, you can put almost anything you want. In this case, I'm using my type pattern variable in the guard. I don't have to do that. I could have a guard that depends on a variable somewhere else in scope. So this is what makes pattern matching absolutely magical, is that it combines type validation, variable evaluation, and variable assignment into a single statement. Going back to this, I am validating the type of control when I see if it matches the combo box. I am evaluating it by checking its property. And if those things are true, it will populate that variable combo box. This is why we can reduce the amount of code so much, is that I'm able to do multiple things in one place. And that all makes sense. It's not like some kind of wizardry where we're doing a bunch of stuff and making the code more complex. It just makes it simpler and more compact. One way you can think of it, and let me preface this by saying this is not valid code, but you could think of it kind of like a triparse if you could also pass in a lambda. Because a triparse will evaluate the input, and if it's valid, assign a variable, which in this case is the output variable. But it also does the selection. It returns true or false based on the parsing. And if it were like pattern matching, you would also be able to pass in a lambda, and based on whether or not the lambda evaluated to true or false, you would parse it or not. Again, this is not valid code. Don't try and do that. So one of the reasons I like pattern matching so much, like I said, it allows you to do multiple things. It's kind of like we put a switch statement and an is operator and an as operator in like a triparse or regex in a blender, and mashed them together and got a language feature out the bottom. More generally, it's a mixture of selection, assignment, and evaluation. So it's a nice little, it's kind of like a three-headed monster, like Fluffy. Let's look at some code here. So you guys are all familiar with the fizz-buzz problem. It's kind of a classic programming kata. And I could have a method like resolve that is going to check each integer for either fizz, buzz, or just the integer number. And this code is fine. You can see all my unit tests are passing. But it's a little esoteric because we have to kind of know what the mod operator is doing there. With pattern matching and another C#7 feature, we could reduce it down to this. Let me kick the font up here for you. So I've got a method called resolve pattern matching. And the first thing it's going to do is it's going to call another method called is multiple of 3, multiple of 5. And that's actually going to return a tuple. This is one of the other language features in C#7. If you haven't seen this, you should really go check it out. It allows us to package up two variables that travel together without needing to create a class for them. And we don't have to use generics. And so I can simply do the one evaluation of my input variable I for mod 3 and mod 5 and return those two Booleans back together. The other cool thing here is that I can name the members of the tuple so I can have multiple of 3 and multiple of 5 as Boolean names. So now what I can do, I call that method, and I'm going to switch on the result. And this is using a different pattern to match. In the previous example, we were looking at the type pattern. This is what's called the var pattern, which basically means that we are going to match on any type, but we're going to evaluate a guard to decide whether or not it matches or not. And that kind of makes sense because we're evaluating on the return type of that method, so it's always going to be the same type. It's going to be that tuple. So what I can say now is for the case of status, when status multiple of 3 and status multiple of 5 return fizzbuzz. And I can do similar things for when the status, or just checking multiple of 3, just checking multiple of 5. And then we still have the default case where we're going to return a string. This code also works. It works just fine. We, in fact, we can change this around so we're using the pattern matching code instead of the older way. If I run my unit tests, then they should all pass again. Yep. Oh. Yep, they all passed. So functionally, it's the same. But I would argue that this code is much more readable, and the code is much more expressive of the problem we're trying to solve. And you can almost read the requirements out of that code. It's great.
Can you please show this function for a moment?
This one here?
Ah, okay. Here.
Yeah, so this is the function call to is multiple of 3 or 5, which is defined here. And this is the syntax for returning a tuple. That's where we're putting the names on it. And this is the syntax for composing the tuple.
Could you give the name to the variable in the switch case, in the switch statement? Now you're doing case var status for every of the cases. Could that be moved up into the switch statement somehow?
Well, so the question was, do we need to have this variable declaration here? And we do, because that's how the variable pattern works. We could actually have cases where inside of a single switch statement, we match on type patterns and the variable patterns. And so it's kind of important that you say, this is the var variable name. This example might not show that as clear as others, but it is there. So the examples I've shown so far were kind of contrived. What I thought would be really interesting would be to look at some real-world examples. And the neat thing about this is that Microsoft is now developing a lot of their code in the open. It's up on GitHub. And a lot of those projects were started before C#7 was a thing. So we can look at how the Microsoft teams implemented code without pattern matching and see how they've changed it now that pattern matching is available. So I wrote a little search tool using Roslyn to, it compiled the code, and then I just searched for the syntax nodes for the pattern matching. And we're able to pull some of these examples out of either ASP.NET Core, ND Framework Core, .NET Core, or the Roslyn project. The ones in Roslyn are really interesting because you're seeing how the language implementers are using their features. So we'll see a handful of those. So this is some code from the Entity Framework code base, or the EF Core code base, I should say. And they're getting this column, and basically the first thing they have to do is check for null. on both the column and the property. With C#7, they actually added functionality. And so the code gets a little bit bigger, but it's doing more. And what they can do is they can remove that null check. So here's the new version of the code. And you can see that we're matching on that expression the same way. But now we're just matching on the types, and that null check is nowhere to be found. One of the reasons for that is in pattern matching, the type will only match if the variable is not null. And so if expression is null, it's going to fall through to the default case. It's actually really useful. It gets us out of a lot of places where you have to see, is this null? Well, it doesn't matter. It's going to fall through the default. I can handle null for any of those cases because it'll fall through. Here's a larger example of code that's using guards. And this actually is already C#7 with pattern matching. But the thing that I wanted to point out in this code is that we can match on the type and we populate that variable. And we can use it straight away in the guard. So we match in the case, and then in the when, we can already use that variable. And then, of course, we can use the variable once we're into that block. Here's another interesting bit of code. Again, already using pattern matching. But I wanted to show you a couple things. One is that just like before with switch statements, we can stack up a couple different cases and have them result in the same block. But this is a case where I'm going to look at the type and I don't need that variable. And so the new syntax here is actually that guy. That's an underscore, and it's now the discard operator. So what I want to do is I want to inspect the type of the variable that I'm switching on, but if I don't care about using that variable again, I just throw it away. So the underscore is basically saying I don't care what this is. The discard operator doesn't only work in pattern matching, it actually works in other places. It is very valuable in pattern matching. But for example, if you want to call try-parse and you don't actually care about the output value, you can just discard it now and accept the Boolean result of the try. It's worth noting that before C#7, a single underscore was a valid variable name, or a very valid identifier. And so if you have code that uses a single underscore as an identifier, you don't have access to the discard operator anymore. If you have code that uses a single underscore as an identifier, you might want to ask yourself some questions about that to begin with. With the exception, Fake It Easy actually uses the single underscore for very similar reasons, basically just saying we don't care about this. But just be aware that that's like, it's a funny little language thing where it could be an operator or it could be a variable name.
Does using Fake It Easy at the same time as using that cause problems? Fake It Easy having defined that underscore as the ignored?
I think it wouldn't necessarily, because in Fake It Easy, the underscore, I think, is a property. Yeah. And so it would be scoped to that object and not just like a bare identifier. Yeah. Here's some code taken right out of the ASP.NET Core code base. And in this, we are going to switch on one of the attributes that we found in the markup. remember when I said I promised I would come back to the whole ordering thing? Okay, now we're back. In this case, the class attribute.value could be an HTML string, and the HTML string implements iHTML content. So in theory, both of those could match on a given input variable. The new thing about switch statements is that the order that they're listed in is now important. In C#6 and previous, because things always evaluated to strings or numeric values, there's no way you could have these collisions, and so the order really didn't matter. Now, because multiple of these things could match, the order is important. So basically, it will evaluate to the one that it finds first. The exception being the default block is always essentially at the bottom. So if you start with the default block, that won't match every single time. But other than that, order is now important. This is one of the examples I showed at the beginning, and it's actually one of the most useful ways to use pattern matching. Remember I said that pattern matching is essentially a way to do evaluation and assignment in the same statement. And so when we have code like this, where we are going to take a variable and try and cast it, which would be the assignment, and then see if that cast worked, which would be the selection, then this becomes a prime candidate for pattern matching. So in this case, I've got this expression, and I'm going to do an as operation on it, which, as you know, if the as fails, it's going to return null, so then we have to do this expression, or we have to check for null. And we're actually going to do that 3 different times for the 3 different types, the expression syntax, the statement syntax, and the global statement syntax. But we can see now, with pattern matching, we can clean this code up right down to this. Because now, instead of having to check the type, we can just match on it. So if the node matches expression syntax, we're going to evaluate in that. We don't have to do the as cast because the pattern will populate the variable already. So that gets a fairly significant reduction in code there. This is another one of those places where we're doing something similar, where we're going to do an evaluation with an is statement. And then if the is evaluates to true, we'll do the cast. This also can be cleaned up, and now the pattern will populate the expression variable, and we can use it right away. But there's another interesting piece of this that I haven't talked about so far. And that's that this doesn't use a switch statement. So pattern matching primarily gets used inside switch statements, but it can also be used as the expression following an is statement. So here I'm saying node is expression syntax, and expression syntax expression is the pattern, and we can just use it right here, right outside of that cast. Lastly, and this is yet another example from the Roslyn code base, we can switch on enums and have guards. So everything we've shown this up to this point was switching on objects. The switch statement in this case is the same as in C#6 because we've always been able to switch on enums. They result in numeric values. But I can now have my case statement on the enum and have the guard. So the guard doesn't have to follow a type pattern or a variable pattern. All right. Any questions on any of the code we've just looked at? Yeah?
Can you put a guard on is? Previous example?
So the question was, can you put a guard on an is statement? Let's find out. So if we had a method and we'll say that it's going to pass in a control. Oh, I don't have, oh, it's not in scope. We'll say object. And actually, let's return a bool. And we will return is string s when s. Oh, apparently I can't do it. It'd be a cool feature though.
Yeah.
Good question.
What would the result be if it wasn't a condition wasn't being met? I guess it'd just be nil.
Well, in that case, is returning a bool, either way.
Oh, okay, yes, sir.
So right now, the is returns a bool based on the type, and so we're just talking about extending that bool to also evaluate the guard.
Maybe you can put an AND operator and then add an adjust a filter on this example.
Right, so I could just do a Boolean.
And as something, as like
Oh.
something, for example.
Yeah, so I could say s dot length greater than 0. Yeah, so I could do that. That's not necessarily pattern matching, other than this is still the pattern matching, but then this is just the evaluation. All right. Any other questions about C#? Yeah.
With reduction in size, is there any increase in performance? I mean, is intermediate language any different using this?
Yeah.
Using the old?
So you're asking, does the performance improve using pattern matching? I don't know. That's a really interesting question. I'll do some research on that, and I'll throw something up on Twitter about it. Because the guys that would know are in the building, so I'll find out for you. Yeah, other question over here.
I think it's that it's actually just syntactic sugar, isn't it? I think, and it compiles to an if else, if else.
That, yeah, so what you're saying is it's just syntactic sugar. I think that's the case, but I don't want to say for sure because I don't know. But let's find out. I'm curious now. All right, so pattern matching is new in C#, but it's actually been around in some other languages for a while. And when you see a presentation by a guy that has an F# sticker or two on his laptop, you know you're going to see some F# at some point. So let's look at what you can do in F#. So in F#, we can have this match operator, and I can match on variable I. And the thing that I want to show you here is that while this probably does kind of what you think it does, where this gets more interesting is, let's say that I take out the default match. So this line basically says, if nothing else matches, fall through. It's kind of like a default. Let's say that that goes away. I'm now getting a little green squiggly. And if I hover over it, you'll see I'm getting an error that says incomplete pattern match on this expression. So the compiler will actually run through and see, is the bonehead programmer writing this code missing something? And as a bonehead programmer, this makes me really happy. This is something, I don't know how hard it would be to do in C#. It would be really cool. I would like it. Where this gets a little more interesting is if we were using something like enums. F# has a construct called discriminated types. But let's say that another color got added. I'm now getting that same error because another possibility was introduced. You could see how in a large code base this would be incredibly useful. In one part of the code base, I add a new enum. In another part of the code base that I've never seen, somebody is switching on what they think is all the enums or was all the enums at the time. And so now that becomes an error to me, and I know that, hey, I added something to this enumeration. Here's this other place. I need to go make some modifications. So I think that's really cool. Another pattern type that F# is called a list comprehension. And so what I'm doing in this code here is I've got a method called what might my list be. And it's actually going to match on the different values that are in the list. So if the list that's passed in starts with 0 and then has 1 and 1 and 2 and 3 and 5 and 8 and 13, and then some tail, some continuation of the list, I will return this string Fibonacci. And then I have a similar one for primes. This is something that I find really fascinating, where I can actually match on the members of the list. An example that might be a little more relevant is trying to evaluate command line parameters to my application. So this is the main method, and I get this list of arguments, and I'm going to cast it to a list. And so now I can match on the argument list, and I can either look for -help or -v or -greet. And in the same way that in C# I could assign values, in F# what I can do is I can look for constants, but also populate variables. So in this case, tail is a variable. Greet is a constant, and so I can use this variable in my output. So if we ran this and I passed in .greet Eric, it would say, hello, Eric. So
Will it match on more name? The name is match.
So you're asking, what if I called this application and did -greet and didn't have anything else?
Yeah.
So then this pattern wouldn't match.
Yeah, okay.
And so we'd fall through to the default case. Just like in C#, if the pattern doesn't match, the variables don't get populated.
So before you move off, it's probably more of an F# question than a pattern matching one, but on your what might my list be, can you match like the middle of a, you find something that matches the middle of a pattern?
So you're asking, could I match on the middle of something?
Yeah, for example, the middle of the Fibonacci.
So what I could do is throw some discard operators in here, which the underscore kind of works like the discard operator. And I could, blank out some of these. And so this would achieve what you're talking about. So now I'm simply not going to look at those first 4 and then match on 3, 5, and 8, and 13.
Could you have like random in front?
Yes,
As
that's
tail is
what
random.
Oh.
that's what I was asking. Yeah. If you
So
Like
could
sliding the
could I, with pattern matching, look for anything in the middle that matches?
Yeah, like a sliding window over your stream or something like that.
Can't you just have
you could do that in F#, but not with pattern matching. So if you guys want to talk about F#,
Probably.
I would love to talk about it more with you, but we will get out of the scope of this talk. Believe me, there's nothing that would make the attendee party more fun than for me to talk about F# for 3 hours.
You need to put the sticker on your back as you walk through.
Are you guys familiar with the Rust language?
Have a little play.
Rust is a really new language. It's cool. It's really low level. It's actually the language that they're using to implement some of the core bits of Firefox, and it's one of the reasons why they're getting such good performance improvements in Firefox right now. But they also threw pattern matching in there. It was interesting to me that they did that because pattern matching is traditionally a functional programming language construct. And Rust is a low-level language. It's a lot like C. But they did throw pattern matching in there. They have the match keyword. And a lot of the pattern matching looks similar to C#. But they have this. This is the range pattern. So now if I have a function that's passing in a grade, which is a 32-bit integer, I can match on anything in that range. So 90 to 100 would match on that first one. So if I had 93, it would match that range. I'd print A. If the value that was passed in was 75, it would match on that third statement and print C. I think this is kind of cool. There's a lot of times in my coding career that I've written code that's like, if a value is greater than or equal to this, and also less than or equal to that. And one thing that's really cool is that this is almost a C# feature. If you go up on GitHub and look at the C# Lang repository, you'll see that this is something that they're seriously considering for C# 7.3. It is still a proposal, might not be there. But yeah, here's the URL. You can go out and follow the status, see if it makes it in or not. Interestingly, the thing that they're hung up on right now is whether 0 to 10 should be inclusive or exclusive. And actually, Rust, I think if you use the 2 dots for the range is inclusive and 3 dots is exclusive. Maybe it's the other way around. But I asked Bill Wagner yesterday about that, and he said that they didn't like that in C#. They didn't think having like a 2-dot operator and 3-dot operator made a lot of sense. Another newish language that has become really popular really fast is Swift. And their pattern matching looks a lot like C#. But they have an additional feature that I really like, which is where you can pattern match in your iteration. So let's say that I have an array of optional ints, which if you've not looked at Swift before, optional is kind of like nullable. Nil is analogous to null. And so I have this array that I'm declaring there on line 1 that has 5 slots in it. 2 of them are nil. Where the pattern matching comes in is this question mark right here. That guy. So what I can say is for case let number question mark in array of optional ints. And then I'm just going to say print found A and then the number. What's cool is that that means that the iteration skips over all the nils. So I don't have to have a nil check every time I go through the loop. It's just going to skip right over. Pretty cool. All right, how many of you guys have ever played with Elixir? So if you haven't played with Elixir, you really ought to go check this language out. It's really cool. It takes pattern matching further than just about any other language that I've ever seen. It does some things that I will not be able to explain in the next 10 minutes. I'd encourage you to go look at it. If you have a Pluralsight subscription, there is a course called Getting Started with Elixir by Nate Taylor that I recommend. If you want some more interactive material, Rob Connery has put out some some tutorials where you're actually kind of writing code as you go. It's pretty cool as well. I'd look that up. But as a C# developer, when I look at this code, I think that those functions are overloaded. I have two functions named first that they're in the same scope and they seem to do the same thing. But they're not really overloaded because they actually take the same number and types of parameters. This is probably foreign to you, but the square brackets indicates that something is a list. So I have two functions, it looks like, named first that both take a list. What that means is that I'm actually pattern matching on the arguments and then selecting which clause to execute based on the contents of the list, not on whether or not it's a list. Right? In C#, we can overload a method, and the right one will be selected based on the argument types or the number of the arguments. Basically, what is happening here is if I call first and I pass in an empty list, it's going to return nil. There's nothing in between the square brackets, so the list is empty. The second clause is going to look at the head, or the first element in the list, and then it will look and make sure that there is a tail, which we're discarding here. Oops. Again, the underscore is the discard operator. And then, since the method is named first, you could expect we're just going to return the first item, or the head. But I found this to be really fascinating, that I could actually pick which one of these clauses I'm going to execute. This is called multi-clause functions. It's not really overloading because they take the same argument list, but it's multi-clause functions. And one thing that's really common is to have a bunch of clauses. So again, going back to that list example I had earlier, I could match on things like match on whether or not the list starts with 1, 3, and 5, or 2, 3, and 5, or 1, 2, 3, and 5. And I'm going to return a string based on which one it is. Now I've got 3 clauses. But the way that you would typically do this in Elixir, the idiomatic way that you would do this in Elixir, is to shrink it down to this, where I'm going to have each method clause have the pattern and then the return type just on that same line. This starts to look kind of foreign to C# programmers, but I think it's really neat. You're doing some really powerful evaluation there in a very small bit of code. If you think about why this works, it helps you understand what pattern matching is in C#. Because really what we have is a couple of different clauses, and we need to select which one of them we're going to do, right? So we've got our selection. And when we pass arguments into a method, the parameters essentially get assigned. And so we have that assignment piece that we have in C# as well, right? So you have the selection, you have the assignment. Elixir also has guards that you can put on methods, but that's actually a little bit outside of pattern matching. You can put a guard on any method. And so you have that same evaluation piece, like C# has in its pattern matching. So let's switch gears back to C#. I think those other languages are awesome. They help us think about pattern matching, but let's be real. When I get back to the office, I'm going to be writing C# code. So let's talk about when you should think about using it. When you have different behaviors based on the type of an input variable, consider using pattern matching with a type pattern. I say consider because this isn't like a law. This isn't always going to be the case. There are going to be other situations where you have different types and you want different behaviors. And what you actually want to do is use object orientation, right? So you have the default behavior in a base class and you override that behavior in the child classes. If you don't control those classes, you might want to consider using pattern matching. That's why I use WPF in the example. I don't control the code for textbox. And so I need to switch on it and get the right behavior for given the type. When you have a case statement with nested if blocks, consider rewriting the blocks to have guards. This is an easy one to pick up visually. If you have a case and then immediately have an if, a lot of times that might be an if variable equals null, or it could be some other, if something else about the variable. Very frequently, you can combine that just into a case with a guard, and that'll clean up your code, get rid of some of those unnecessary if statements. When you have an is check immediately followed by an as cast, consider just using the is statement with pattern matching. This is probably the most obvious one. This is the one that's like, if you see this, you should almost certainly use pattern matching. Because that as cast is now completely superfluous. Just use the type pattern, you get the variable assigned in the right time, it'll be fine. And in a similar way, if you have an as cast followed by a null check, combine that into the type pattern with the is statement. There's no reason to use the more verbose way to evaluate that. I really enjoy this feature. I really love pattern matching. That's why I'm talking about it. But this is the one thing that I want you to remember. This is the most important slide in the whole thing. Just appreciate the fact that you now have one construct that represents 3 different functionalities. It allows you to really clean up your code. It makes it more expressive. It makes it easier to understand. All those ilities that we want in our code, pattern matching helps you get. I know we've got the attendee party coming up, so I won't run any longer. If you have further questions, please let's come up and talk about it, or find me at the attendee party, or find me tomorrow. I'll be here all day. I'd love to talk to you more about this stuff. If you have questions later, you can certainly hit me up on Twitter. That's the easiest way to find me online. If you want to see any of the code that I showed today, it's up on my GitHub, also at PotterEric. I've blogged about a lot of these topics if you want to see further explanations. My blog is at humbletoolsmith.com, and you can find the pattern matching tag there. So I hope you guys take this. I hope you guys start using it. It's great. It's one of those features that really makes the language move forward in awesome, awesome ways. So thanks, guys.